Thank you for attending today's webinar. My name is Jennifer Adelstein, and I am the Marketing Assistant for Industrial Controls. Today's webinar is on humidity measurement technologies and best practices that will reduce drift and minimize out-of-tolerance incidents, presented by Bill Hopler of Industrial Controls and Greg Gawowski of Rotronic. The presentation will take about 35 to 40 minutes, and everyone will be muted so we don't experience any outside noises that would disrupt the presentation. After the presentation, we will take some time to answer your questions, so feel free to type in your questions in the chat interface on your control panel located on the right-hand side of your screen, and they will be addressed at the end. We will also open it up to voice questions, where you can raise your hand by clicking the hand icon on your control panel, and you will be unmuted so you can communicate directly with the speakers. So at this time, I'll pass it over to Bill Hopler to get us started.
Thank you, Jen. I'm here with Greg Gawowski, who has pretty much spent his entire career focusing on humidity measurement and control, both with end users, farm biotech, OEMs, consultants, and pretty much every application that you can think of. I myself have done webinars for industrial controls on flow meters on combustion control and combustion control, but today our webinar is on measuring and maintaining humidity sensors in pharmaceutical applications, although what we're discussing also applies to other businesses, power plants, and chemical plants. So we represent at Industrial Controls over 150 industries and leading manufacturers, and it's interesting because probably 10 of them have humidity solutions. So that's what challenges that we face and you on the webinar face, is how to pick the right brand, the right technology in order to maximize their performance for the application. And we pride ourselves at Industrial Controls as having a good product mix, but more importantly, the solutions mix. And what I mean by that is that we are able to guide a customer towards a solution based upon the criteria and the questions that we ask, instead of just asking our customers to come up with a part number, allowing us to give them price and delivery. So we have inside people that can guide you towards the pricing and whether or not these items are in stock. But the technical solutions is the kind of thing we like to focus on. We have field people that go out and do site studies and help a customer with the requirements. And today our discussion is on humidity measurement. And what we're going to talk about, for those of you that are in the FDA validated side of the business, we're going to talk about what the FDA looks for when they go out and do audits on humidity, best practices for reliable humidity measurements, and also the ability to maintain them, humidity sensor technologies, of which there are many. What's new in humidity measurement and technology? I think you'll find that there are some software capabilities and some networking features that you may not be aware of. And then, of course, humidity sensor calibration procedures, how to not just pick the right sensor technology, but how to maintain it properly. So why does the FDA focus on humidity? Many of you know this, but drugs are adversely affected by moisture, and this includes the development phase, manufacturing, and warehousing. In fact, up until about 10 years ago, the FDA did not require manufacturers to actually monitor and archive humidity and temperature in warehouses, and now, of course, they do. Humidity can cause degradation of the product and unwanted impurities, and high humidity, of course, can cause microbiological growth. So the kind of things that FDA will look for is they'll look at areas where humidity may not be monitored and should be, things like warehouses, documentation, of course, SOPs that indicate the desired humidity levels and tolerances, of course, your chart records, whether they would be paper chart records for humidity and temperature, or in the case of electronic records, assurance that those electronic records meet 21 CFR Part 11. And then, of course, documented excursions. And that, I think, is going to be the point of our webinar today, is to guide you towards picking the right technology, maintaining it properly, so that you minimize the excursions. And this relates both to FDA-related applications and also things as simple as air handlers, because excursions in air handlers cause downtime, which could, in effect, cause downtime in production. So everyone probably knows that these documented excursions, incident reports, maintenance records, and corrective actions are very time-consuming, and in some cases require quarantine of the products that were manufactured until it's determined whether or not the effect of the excursions has affected the product quality. And then, of course, calibration records as found and as left documentation, and calibration intervals per the individual company's SOPs. So we're going to talk today about the best practices for humidity measurement. Greg is going to speak to understanding better about humidity and the effects of its parameter. It's just like picking out a flow meter or a temperature sensor. The more you know about the technology and what's available, the better chance you have of picking the right technology. Be aware, of course, of external factors which could affect the selection. Choose the correct instrument. Follow the manufacturer's instructions. Ensure a proper calibration. Keep records and spot check performance. And with that, I'm going to turn this over to Greg Gawowski.
Thanks, Bill. Good morning, everyone. Thank you very much for your time this morning. We appreciate you joining us. Relative humidity, it's always, if you're going to be measuring it, it's always a good idea to understand a little bit about it. And probably the most important thing you need to know about relative humidity is that it's a function of temperature. Basically, relative humidity is a ratio, and that ratio is the partial vapor pressure over the saturated vapor pressure. And that saturated vapor pressure is determined by what the temperature is. On this little graph here, this is a small little snippet from the psychrometric chart. And basically what we're trying to illustrate is that blue line on the graph is the saturation curve. And there is your equation that shows basically percent RH is 100 times the partial vapor pressure of water over the saturation vapor pressure, again determined by temperature. In this example, we have chosen the temperature of 80 degrees Celsius. And we know from our saturation tables and also from this chart, at 80 degrees C, if you were to move directly vertical up to the saturation curve, you can see that corresponds to about 480 millibars. And in this example, the customer or the end user has 200 millibars of vapor pressure. So how do we determine relative humidity is 100 times 200 over 480 equals 42%. And again, I'm just trying to emphasize the temperature effect on here in these next few slides. In this example on the slide, what we're showing is a temperature of 60 degrees Celsius. And without adding or taking away any moisture, if we were to reduce the temperature to 40 degrees Celsius, you can now see that we are at a saturated condition where we weren't before. And the next slide is just going in the opposite direction. We have a temperature of 60 degrees Celsius with a known moisture content without adding or taking away any humidity or any moisture. If we were to increase that in temperature up to 90 C, you can see we are that much farther away from the saturation curve. Therefore, you're going to have a much smaller relative humidity value. As a general example, temperature increases. As temperature increases, the ability for the air to hold moisture increases. And conversely, as the temperature decreases, the air can hold less moisture. I'm sure you're familiar in this hot, humid summertime, you can practically see the haze on the streetlights, or after a rainstorm, you can feel the humidity in the air. You can breathe it. That air can hold so much more moisture. And conversely, on a very cold winter day, you might be close to saturation or have a high humidity point on that cold winter day, but you don't feel it. Your skin is dry and cracking because there's so much less moisture in the air.